adjust there. Okay, let's get started. Today we are going to start our unit on graphs. So you're going to learn how to graph sine, you're going to learn how to graph cosine, tangent, cosecant, all those things. This is definitely very new material. It can pose some challenging pieces. We are just covering two sections, namely 5.3 and 5.4. As we cover those sections, you will have a test on it probably about 8 days, my guess is. Okay? So, well, how long would you like to wait before you test over two sections? 3 days? 4 days? 5 days? How about 8 days? 8 days sounds good. So, let's look at the basic graph of sine and cosine. You need to have out a couple sheets. First of all, as you look to the back side of this, you'll see this sheet that says trigonometric parent function graphs and notes. This will be the notes that you're provided with on the test that you will take in the next 8 days or so. What I would also like you to have out is that sheet of notes that I gave you that has the unit circle on it. And I would encourage you to have that out all the time, as I've said before. It will help you, unless you are a master at the unit circle, which may be the case. But if you're not, you might want to have that out. So we're going to look at the graph from 0 to 2 pi. 0 to 2 pi. And we're going to look at y equals sine of x. This is a function. You could also write it as f of x is equal to sine of x. And the idea is if we plug in something for x, we get something for y. If we plug something in for x, we get something for y. Now, namely, what we plug in for x is we plug in certain degrees or we plug in certain radian values. So what goes in for x is angle measure. And what comes out is just some decimal, we'll say. So really, you're left with some coordinates. An xy coordinate. X is generally your theta value, whatever your angle measure is. And then y, again, is just some arbitrary number that pops on out. So we're going to start generating values for this graph, y equals sine of x, or f of x equals sine of x. And we're going to see what it looks like and the shape that it takes. And I'm going to look at it over the interval of 0 to 2 pi. So if I mark right here 2 pi, and I divide it up into, I'm going to divide up into 4 pieces. We'll talk about that later. Look at the intervals I divided it up into. 0 to pi over 2. Pi over 2 to pi. Pi to 3 pi over 2. And 3 pi over 2 to 4. What do those 4 intervals represent? 90 degrees, so they represent the 4, starts with a Q, rhymes with quadrants. Yes, quadrants, very good. So we are looking at the 4 quadrants where sine takes on different values. Now, in the unit circle, you have a bunch of different terminal points. Is sine equal to the y value or the x value? The y value. So let's start at 0. If you have an angle of 0, look at your unit circle, an angle of 0, what is the y value of your terminal point? 0. Your terminal point, if you look at your sheet, is 1, 0. And the y value of that is 0. So if you take the sine of 0, you get 0. Put a 1 up here and negative 1 down there. Let's try another point. Notice this is pi over 2. I'm now going to try pi over 6. All right, that's the next one on our unit circle. If you take the sine of pi over 6, what's the y value of pi over 6? 1/2. So the sine of pi over 6 is 1/2. If you look at your unit circle, what is the y value of pi over 4? Square root of 2 over 2. And the square root of 2 divided by 2 is 0.7071. Whoop, sorry. .7071. So that will bring us about 3/4 up the way. At pi over 4, about 3/4 up the way. Now we have pi over 3. What's the y value of pi over 3? Square root of 3 over 2. If you take the square root of 3 and divide it by 2, you get 0.866. And finally, pi over 2. If you look at pi over 2, which is 90 degrees, what's the y value at pi over 2? 1. So the sine of pi over 2 is 1. So there's some points. You tell me, if I were to draw a curve through that, what are some other shapes that we've graphed before that look similar to that? See anything? Cubic, maybe? Somebody said first hour, they said it kind of looks like we're starting a square root. Some people say it's an upside down parabola. Well, those are good analogies, but it does look something a little bit unique from that. And if we just head on here a couple more points, you'll see exactly what's going to happen. If I went to my next spot, which would be 2 pi over 3, what's the y coordinate for 2 pi over 3? Square root of 3 over 2. And what's the next one? Square root of 2 over 2. And what's the next one? 1/2. What is the y value at pi? 0. And it's actually going to continue to repeat itself. Look at this. If I'm in the first quadrant, is sine positive or negative in the first quadrant? Positive. Look, this is above the x-axis. Is sine positive or negative in the second quadrant? Positive, so I'm above the x-axis. In the third quadrant, is sine positive or negative? Negative, so it's going to drop below the x-axis. And how about in the fourth quadrant, positive or negative? Negative. So the sine graph is actually going to look something like this. How would you describe that shape? The wave. Yeah. Sine graphs like a wave. And that is very important because there's a lot of things in nature that have wave-like behavior. For example, my voice travels to your ears as a wave. Light travels as a wave. Seismic tremors travel as waves. Everything travels. You guys, your signal for your cell phones travels as a wave. And so understanding the relationship between waves and what happens in this real world is important. And so modeling functions in terms of sine is something that we like to study. What is the maximum value that sine achieves? What's the maximum y value that it reaches? 1. What's the minimum value it reaches? -1. The amplitude is how high or how low it goes from its center. How high does it go from the center spot? 1 unit. The period is how long it takes to repeat itself. So if I look at this spot right here at 0, 0, it's headed up. When is another time where it's at 0, 0 and it's headed up? All the way over here. Here it's headed down. Over here, I'm headed up. So as you can see, this is one full cycle or revolution from 0 to 2 pi. Every 2 pi, it will repeat itself. Well, what is one trip around the unit circle? 2 pi, and that's when it starts to repeat itself. We go around the circle again. Maybe you can see the connection. It is all connected, and That's the nice thing about trigonometry. It's a new language, but it's all connected. So those are the important pieces of the graph. Any question on those? Let's try cosine. I'm going to look at cosine over a very similar interval. 0 to 2 pi, same interval. I'm going to divide it up into 4 pieces to represent the 4 quadrants. There we have it. And I'll start by plotting points just the same. And I'm going to start at 0 degrees. If you look at on your unit circle, versus cosine, the x value or the y value? X value. So what is the x value at 0 degrees? Or 0 radians? 1. So the cosine of 0 degrees or 0 radians is 1. Cosine of 0 is 1. Let's try pi over 6. What's the x value for pi over 6? Square root of 3 over 2, which is 0.866. What's the x value at pi over 4? Square root of 2 over 2, or 0.707. What is the x value at pi over 3? 1/2. And what is the x value at pi over 2? 0. What do you notice? It's doing the same thing. Is cosine positive or negative in the first quadrant? Positive. Is it positive or negative in the second? Negative. Positive or negative in the third? Negative. Positive or negative in the fourth? Positive. So this one is going to look like this. Similar graph. I would challenge you to think about this and suggest that the sine wave and the cosine waves are exactly the same, except for the cosine wave is shifted over 1 quadrant. If I take this cosine wave and I shift it over 1 quadrant, watch me. I'll shift it over 1 quadrant to right there. I bring it up. It fits right on there, right? Same graph, just shifted over 1 quadrant. That's all the difference is, okay? And that's the relationship between sine and cosine. They differ by simply 1 quadrant, or pi over 2. So the characteristics are identical here in that the maximum value is 1, the minimum value is -1, the amplitude is 1, and the period, again, is 2 pi. And those are your 2 chief parent functions for trigonometry. If we can learn how to graph sine and cosine, we're in good shape. Now, we don't want to just leave sine and cosine like this. We want to perform all sorts of interesting shifts and transformations to them. For example, we would like to do something like, say, y equals -4 times the cosine of 2x minus pi plus 3. You know, we want to be able to graph something that looks like that eventually. That's a lot more interesting. But we need to take baby steps in order to get there. So let's talk about the general shape of a sine and cosine curve. If you see y equals some number times the sine of bx, the amplitude is simply the absolute value. Amplitude is always positive. Absolute value of a, the number in front of the sine, or the number in front of cosine. Taylor, question? Amplitude is the height of the function from the middle. The period does involve 2 pi, but we divide it by whatever number is multiplying in front of x. And it's the same for sine and cosine. These formulas are on the sheet which I gave you. If you look here, it says sine and cosine. It lifts the forms. It says amplitude, absolute value of A, period, 2 pi over B. All that is listed for you. This is the sheet that you get on the test. Okay, we flip over to the other side. Tomorrow we'll do example 1 where I'll be providing you a sheet to talk about period and amplitude a little bit more to help your mind a little bit. You will have an assignment tomorrow. You will not have an assignment today. Today we just want to work through about 6 examples here and figure out where we're at. And we start here. Find the period and amplitude of the following graphs. I'm going to start with the amplitude for each one. Who can tell me the amplitude of A? 2. Very good. In order to find the period, I use a formula. It's 2 pi divided by what? B value, which is 3. So the period is 2 pi over 3. So every 2/3 pi, which everyone knows is 120 degrees, right? Every 120 degrees, this will repeat itself, as opposed to every 360. So this one is a little bit compressed horizontally. This one, what's the amplitude here? Positive 3. Amplitude is always positive, never negative. What do you think happens if we put a negative in front of it? Flips over the x-axis. It's a vertical reflection. So yes, the negative 3 does make it so it's a vertical flip, but it still has, you know, an amplitude of 3. In order to find the period, I take 2 pi and I divide it by the number that's multiplying x. What number is multiplying x? 1/4. So 2 pi divided by 1/4. I don't divide fractions, I multiply by reciprocals. So that would be 2 pi over 1 times 4 over 1, which is 8 pi is the period. So this graph, instead of repeating itself every 360 degrees, it repeats itself every 1,440 degrees, which is 8 pi. So it's stretched out a lot longer. How about C? What's the amplitude here? 1. Very good. Period. I take 2 pi and divide it by what is multiplying x? 2 pi over 5. Again, I don't like to divide fractions, so I could write it as 2 pi over 1 times 5 over 2 pi. And I get 5. Now, this tends to confuse people for a couple reasons. First of all, they want to grab the x. You don't grab the x. It's kind of like y equals mx plus b. The m sits in front of the x as the slope. Here, the b value obviously affects it. The other thing is that people always think that a period has to have pi in it. No. In this case, the pi divides off, as you see. You're just left with 5. The last one, D. What's the amplitude here? 1/4. And the period, 2 pi divided by pi, very good, is 2. Any questions on amplitude or period? No? All right, well, we're going to do A and B, and then we're going to graph these two, and that's where we left off during second hour. I know that we'll be a little bit done early, but that'll be okay. You guys look like you're hungry for lunch anyways. What's for lunch today anyway? Macaroni. Anybody ever had homemade macaroni and cheese? Isn't that phenomenal? It. What I love to do. This is kind of one of my favorite meals. Barbecued chicken off the grill. Barbecued chicken off the grill. Um, twice baked potatoes. Cornbread muffins with honey on top. Macaroni and cheese. And barbecued baked beans. My house. That's what I make. I'm the cook in the family. I'll make that meal like once a year. Well, I mean that's once a month. I'll make probably once every couple weeks. I'll make the barbecue chicken on the grill. Then we'll have some type of potatoes. Then we'll have cornbread muffins, and then we'll have like a salad with it. And we love cornbread muffins in my family. They're really yummy. Yeah, drizzle a little honey on top. You guys like cornbread muffins? How about baking powdered biscuits? That's the last thing I made the other night. I made some baking powdered biscuits. We had the barbecue chicken. No, we had pork chops. We had pork chops. Yeah. 2 nights ago, I made pizza. I made homemade pizza from scratch with the dough and everything. Oh, it's phenomenal. I'm gonna make a YouTube video on how to do the homemade pizza, and I'll offer extra credit for people who actually go and make the pizza and watch it. So yeah, won't that be fun? Yeah. What? Parker's question is, do we have to bring the pizza in? No, you have to take a picture. I thought you said, is the pizza any good? The pizza is phenomenal. Oh, I keep it very simple. I keep it, pepperoni and we had some Italian sausage the other night on it, which is really good. Not just hamburger, Italian sausage. But we just like just regular pepperoni. But the crust is phenomenal. It's phenomenal. So you'll have to you'll have to see it. I'll make a video for you. All right. I could see you guys get kind of sleepy out there, so I resurrected. There's some smiles out there now, and you guys a little bit better. So now you're hungry. So now we're actually behind second hour, so we're running out of time. All right. Example 3. Describe the relationship between the graphs of f and g. Consider the period and the amplitude. Okay. So let's look at the amplitude first. What is the amplitude of sine of x? Yeah, the amplitude is just 1. How about for g of x, what's the amplitude? 1 as well. Let's look at the period for each. What's the period for f of x? 2 pi. What is the period for g of x? Pi. So if you notice, one has a period of 2 pi, the other one has a period of pi. What does that mean? It repeats itself twice as often, right? So we would say g of x repeats itself twice as often as f of x. What else changes this graph? What else makes it different? The negative does what? Flips it over the x-axis and is reflected over x-axis. A vertical reflection. So the idea is you should be able to look at two graphs and understand how they're different. You really should. This may look like a lot of confusing material. I think if you talk to people who took trig last year, we did a really, really good job going through this stuff, and you're going to learn it very well. And you're going to do just great. F of x equal, this test is much easier than the test you just took. So I think. I think you guys would agree after you took it too. F of x is cosine of 3x, and g of x is negative 4 cosine of 3x. So what is the amplitude for the first one? 1. What's the period for the first one? 2 pi over 3. What's the amplitude for the second one? 4. What's the period? 2 pi over 3. So, true or false? They repeat themselves with the same often-ness. True, sure. Horrible language. Then how are they different? Yeah. One goes 4 times as high as the other and 4 times as low. So one is stretched 4 times the other one, right? G of x is stretched by a factor of 4 and reflected over the x-axis. Any questions on that? Let's graph them. See, I always go back to when I was your age. I thought lines were just so boring. It's like everybody could draw lines, right? I want to know how to draw the difficult stuff. And when I saw how easy it was to actually draw the difficult stuff, I thought, well, that's really cool. It makes you look smarter than you probably really are, right? Because it's really not as tough. So let's make you guys look smarter than you really are. No, okay, I'm sorry. That's just a way of me saying I look a lot smarter than I really am. I'm really actually kind of a dumb person. So. Nathan does not believe that. Nathan, you're a very nice guy. If I can make wooden things. All right, great. Very, very well said. Very well said, Jalen. Said with just very good, just with great grace did you communicate that. That was wonderful. Okay, front page, steps for graphing sine and cosine. Number 1, identify amplitude. Mark max and min on the y-axis. As you're writing, I will give my disclaimer. I will teach you the method that I feel is most useful for graphing. If you want to try a different one, go ahead. Because I didn't do it this way in high school. But this is the best way that I can teach it. And if you like something else, go ahead. Figure it out. Do it. Do whatever you want. I don't care. But then don't complain to me if you get it wrong. Okay? So if you like a way, go ahead and do it. That's fine. I definitely went by my own, beat of my own drum. Okay? I definitely did that. Second thing I'm going to say, if I can't read your graphs, they are wrong. Raise your hand if you're predisposed to have handwriting that is below average. Raise your hand if your handwriting is below average. Come on. Okay, so, all right, looks like me, Ryan, and Nathan, and Alex. Okay, so we're the only culprits here. When I was in high school, my handwriting was definitely below average. If I can't read it, I'm sorry, I will mark it wrong. And every once in a while, then somebody comes to me and said, well, this is what I meant. And I said, well, I'm sorry, I can't read it. They're like, well, it's right there. Well, their graphs look like this. Okay? And this is their axis. Okay? So they divide it up into 4 parts. 1, 2, 3, 4. That's their 4 parts. Here's their bottom. That's their top. Okay? And then this is sine. Okay? And so, you know what? As they explain it to me, they actually are correct. But I don't care. Because if you can't communicate to the real world, you don't get the job. So I got to understand what that means, Nathan. That is horrible. So if you need to do a reality check and say to yourself, I need to improve my handwriting, do it. I did not always have good handwriting. I know it's not perfect, but it's much improved. All right, that's the first step. Identify amplitude. Second step, identify period. divide into 4 congruent intervals. And number 3, this is the last one. Identify starting point and direction. Everybody got it? Good question. Jalen says, are the 4 congruent intervals 2 pi, 3 pi over 2, pi, and pi over 2, and 0? Very often, yes. However, if your period is 2 pi over 3, then that changes. That's only if your period is 2 pi. If your period is different, then it changes. So let's give it a shot here, okay? All right. Y equals negative sine of x. The first thing I do is identify what? What is the amplitude? Amplitude is 1. I mark the max and the min on the x-axis, or on the y-axis. 1, negative 1. Done with step 1. I go to step 2. What's step 2? Period. Period is 2 pi. I mark 2 pi. I divide it into 4 congruent sections. Whoop. Sorry. So I've done my first half of my work. I've divided up the period appropriately. I have the max and the min. Now, the third step for these type of graphs is I need to be able to identify the starting point and the ending, or in the direction. So if I'm sine at 0, is sine equal to 0 or 1 or negative 1? What is it? Sine starts at 0. And if you look at the original graph, what we refer to as the parent function, sine starts by going up at 0. Well, this is negative sine of x. So it's going to start going, yeah, you're going to take this graph and reflect it over the x-axis, and it's going to start going down. So let's grab that. I'm going to plot that point right here, and I'm going to start going down. Now, I've divided my quadrant up into 4 spots. And the reason why is I want to make it easy on myself as I plot. I don't want to plot, square root of 2 over 2 and square root of 3 over 2. I just want to plot 0, negative 1, and 1. So if it goes down at pi over 2, instead of being up here at positive 1, it'll be down here at negative 1. Where will it be at pi? 0. Where will it be at 3 pi over 2? Positive 1. Where will it be at 2 pi? So, good question. How do we know that? For some people, sometimes this is a confusing piece. I just kind of took these values and I flipped them. At pi over 2, it's up at 1. How do you know that? If you look at your unit circle, the y value of pi over 2 is 1. So I flipped that over right here. At pi, it's 0. The more you guys can memorize where a sign is at these values, the more that will really help you. Okay? Memorizing these pieces is very helpful. So if I reflect that over, I get this shape. And now I'm ready to draw my graph. Oh, I like to do this. Okay? You don't have to do it, but I like to. So I go negative pi over 2. I like to get a point over there as well. That really kind of helps my graph. And so if you look at this, I don't mean to brag or anything, but I really like my sine graph. Nathan, can I see yours? Nathan, that's pretty good. That's a very good improvement. That's very good. Good job. It is not as good as Tyler's. That was inappropriate. This is much better as well. So, Fernando, it's okay. All right, let's try this one right here. Amplitude. What's the amplitude? What's period? So I mark off 3 and -3. That's my max and my min. And then I take 2 pi and I section it off into 4 congruent sections. And there we have it. Oh, I like to put that one back there. There we go. So I've done those first 2 steps already. My last step is to identify the starting point and the direction. Where does cosine normally start? It starts up at the top normally, doesn't it? Normally starts right up here at 1. Well, in this graph, being it's multiplied by 3, it will start up at 3. Very good, Taylor. So we're way up here at 3. Does it start by going down or start by going up? Down. So at pi over 2, it will be at 0. At pi, it will be at -1, or -3, excuse me. Then 3 pi over 2 will be at 0, and 2 pi will be at, yep. Isn't that pretty? Here's what I love. If I change my window to be a negative pi, and my x max to be a positive 2 pi, and then it looks like my scales are every pi divided by 2, and my y min is -3, my y max is +3, and I need to work in radians, not degrees. We are working in radians, right? As I graph this, 3 cosine of x look at that. A plus. It's identical. Come on. How do you do better than that? We'll pick up tomorrow. Nice work.